Hi class, welcome back. So we're gonna jump into chapter 4, and this chapter we're gonna introduce work with exponential and logarithm functions. So pretty much we're gonna try to do this exactly as we did with the other functions, um, but using now exponential and logarithm functions. So that is finding the derivatives, finding the critical numbers, if any, um, finding where the function is increasing, decreasing, and so on and so on. And we're gonna use this to also work with some board problems and in the next few sections. So, quick review. This is a section of review that we have done earlier in the semester as well, but I feel like this is important for us to have a quick review. So, let's begin. So we're going to review the exponential properties, and we're also going to review the natural exponential function. We're going to talk about more the exponential function in the next section. So what are the exponential properties? So the laws of exponents allow us to rewrite any algebraic expression that involves exponents. The last three listed here are all really definitions rather than rules. So some of you guys are remember some of the, well, you probably already remember these rules, but some of these rules that we have here is when you multiply two bases, then you add their exponents, right? This needs to be done. This can only happen whenever you have the same base, right? You can add their powers. When you have the division of the same variable, then the exponents are subtracted, right? A minus b. Interesting enough here, consequence of this, the maybe is not mentioned here, but it's sort of important as well, is the idea is this came from the idea that you have a x over x to the a, x to the b, and this gives us x to the a minus b, right, over 1. Well, you can try the same thing, but in the other direction, right? So you can have, or you can have x to the a or x to the b, and what you can do is you can do the subtraction, but in the other, in the denominator. The only difference here is that the order of the subtraction. Now instead of subtracting b, you're subtracting a, right? So that's also sometimes convenient for us to remember that you can work this way as well. The next one that we have here is whenever you have a power, a variable with a power raised to another power, then instead of adding them, we have to remember that these are being multiplied, right? So here I multiply them, and as a result, right? And we have examples below, but I'm just going over the rules real quick. Whenever you have a product inside and raised to a power, then everyone in the factors get the same power. The same idea happens if you have a quotient, then you're dividing both both variables by the same power. Also remember that any variable raised to 0 power is equal to 1, provided that x is not equal to 0. Although in some cases 0 to 0 is still defined to be 1, but very rare. And the other one is that you can change the power, right? You have x to the negative n, you can move the variable to the denominator to change the sign. Provided again that x does not equal 0, and also x to the 1nth is the same thing as the nth root of x, provided again that x is not equal to 0. Alright, so let's jump into a few examples here. And just real quick, if we're asked to simplify this, then what we need to do is work with this first, and this is going to give us the fact that we have a third power. That means that, and you also have two factors in here, then the two factors are going to get the same power, right? 2 to the third times x squared to the third power, right? If you think about it like this came from this rule right here, right? And then carry the 4x, right? Here we're just doing algebra. We're not doing anything about calculus. This is pure algebra. And then we can simplify this by saying, oh, well, 2 to the third is 8, and x to the second to the third. Remember what happens here when you have a power raised to the power. We have this case, right, where you multiply the powers. So this will be x to the 6 times 4x. And then when you multiply, remember we multiply the coefficients with the coefficients. That gives us 4 times 8 is 32. X to the 6 times x Remember that goes back to multiplying the same variable. We add the powers, right? So that gives us x to the 7, and that's it for that, right? The next problem here we are going to simplify as well. One technique that we can think about is that, or remember, since we have a negative power, we can move this to the denominator, and because this has negative power, this can also be moved to the numerator before we actually take the exponent. So what I'm saying here is we're going to have x squared on the bottom, because we can change the variable to the denominator as long as we change the sign value, and the same thing with the y. We move it to the top because they both have the negative sign. We end up moving both of them, but if only one had a negative sign, then that's the only one that's changed. And then we still have the second power here. So now, because they both have the same power, and this is a quotient, by using this property right here, they both get the second power. What I mean by that is we have y cubed raised to the second power and x squared raised to the second power. This gives us, again, a power raised to a power means a multiplication of powers, and then the bottom as well. A power raised to a power is a multiplication of power, so that'll be 2 times 2 is 4. And that's it, right? The next one, we're going to talk about the natural exponential function. The natural exponential function comes from the idea of taking the limit of this function right here as n goes to infinity. This ends up being a special type of value, which gives us the e value, this natural exponential. This actually has a specific value. It is infinite decimal, and so if you had e to the 1, this will give us, if you try this in your calculator, this will give us 2.71828, so on and so on and so on. But it was developed, it was designed from here, right? It came from somewhere. And in the next section, we'll talk about why, and why that's sort of kind of where that sort of maybe it was introduced. So in the first example here, we're asked to find 3 times e to the 4 raised to the 0 power. Well, remember that anything raised to the 0 power is going to be 1, right? And the next one, we have multiplying these two numbers. So when we multiply, right, it's the same thing as we had negative 2 times e to the negative 2 times 5 times e to the 5. Everything's being multiplied here. There's no addition, right? So there's no distribution. So when we do this, we multiply the values negative 2 with 5. That gives us negative 10. E to the negative 2 times e to the 5th gives us 5 plus negative 2, which is e to the positive 3, right? And then lastly here, we have two values here, two variables, well, one variable and one value e, but nonetheless here we can combine these two and combine these two. So what I'm going to do here is I can do it in two different ways, but I'm going to try this. E to the negative 7 minus 3, right? Because this could be subtracted. Same thing here, x to the 6 minus negative 2, right? All over 1, there's still a 1 on the denominator. And the first one we get e to the negative 10, and in the second one we get 6 minus negative 2, which turns into a plus. So 6 plus 2 is 8. And because this one has a negative power, this will go into the denominator, right? Right. And there you go, right? So this was a very quick introduction